Correct. My screen is visible to everyone.
Yes, sir.
Oh, okay, right, fine. So first 5 minutes we can re recall what we discussed in last class, right? So last class we discussed about the introduction of the IC engines. Excuse me. Right. So the heat engine, right? The heat engine is a device which transforms the chemical energy into a thermal energy, as well as the thermal energy it is utilized for a mechanical output, right? So that is called the heat engine, right? The heat engine is classified into two categories, right? One is the external combustion engine and internal combustion engine, right? For the external combustion engines, the combustion will be takes place in the outside of the engine or system. That but in the internal combustion engine, the combustion will be takes place inside the system, that is inside the cylinder or inside the engine, right? So these are the examples of the external combustion engine, like the steam engines and the power plants, right? So here the combustion will be takes place in the outside the engine component, right? Outside the system, right? So for the internal combustion engines, we have two types of engine. One is the continuous IC engine and the intermediate IC engines, right? So for the continuous IC engines, the product of the combustions, right? The product of the combustion of the fuel enters to the prime mover as it is a working fluid, right? So here the combustion will be in a continuous manner, right? But in the intermediate IC engines, the fuel the fuel in combustion takes place inside the cylinder, right? These are the examples of the internal combustion engine and the advantages, right? So for the IC engines, it's a simplicity one, it is compact one, right? Then the initial cost will be low while comparing to the external combustion engine, right? And it requires a less space occupied and the efficiency, right? So the higher brake power thermal efficiency, and it is easy to start at cold conditions too. Then the disadvantage is we can't use the solid fluids, right? We can use only the gas fluids as well as the liquid fluids, right? So we can't use the solid fuels. So in the IC engines, we have a lot of reciprocating as well as the rotary elements, right? So due to these elements, the mechanical vibration will be occurs, right? So these are the disadvantages of the IC engines. Then the classifications, right? According to the many factors or many criteria, right? We can classify the IC engines, right? So according to the thermodynamic cycle, we can classify into three types, right? Auto cycle, diesel cycle, and dual combustion cycle. And according to the fuels used, right? Petrol engine and diesel engine, as well as the gas engine, and the number of cycles: two-stroke cycle, four-stroke cycle. Then the method of ignition: spark ignition and compression ignition. Then the number of cylinders: single cylinder, multi-cylinder, and the cylinder arrangements. Then the cooling methods, right? Air cooled and the water cooled engine. And then depending upon the applications, right? Depending upon the application, we can classify into category of engines, right? So these are the symbolic representation of the ICE engines classification, right? So for the ignition system, we have two types of ignition. One is the SI engine as well as the CA engine, that is spark ignition and the compression ignition, right? Most of spark ignition is the category of the Otto cycle, and the combustion ignition in the category of the diesel cycle, right? So for the working cycle, Otto cycle, diesel cycle, and Breton cycle. Then number of strokes: two-stroke, four-stroke, and the depending on the application, it has many, right? Then the cooling system: air cooled and liquid cooled. Number of cylinders: single cylinder and multi cylinders, and the cylinder arrangements. Then the IC engine parts, right? So for the IC engine, what are the parts are there and what is the its functions, right? So here for the IC engine, we have a reciprocating piston, right? So piston is used to reciprocate, and it is used to transmit the power, right? So and here we have two valves. So it is called as the inlet manifold and it is called as outlet manifold, right? So for the inlet manifold, the air and fuel mixture will be comes into the inlet manifold, and the exhaust gas passes through the atmosphere or passes through the silencer through the exhaust manifold, right? So inlet manifold and outlet, that is inlet manifold, exhaust manifold, right? Then where the combustion will be takes place, right? Inside the cylinder, right? Inside the cylinder, the combustion will be takes place here, right? So that is called as the combustion chamber. Then it is the cylinder block. Then the connecting rod, right? The connecting rod which is used to connect the piston as well as the crankshaft, right? The connection between it will connect the piston as well as the crankshaft. Then the crankshaft, it is a mechanical output element. Mechanical shaft is the output element. Then the outer casing is called as crankcase, and here the piston will have a different type of rings, right? So why we are using the rings means we have to dissipate the heat from the cylinder, right? We have to cool the engine, right? So in this a groove shaped element is there. In that groove shaped element, a tight sealed rings will be there, right? The rings will be used to cool the cylinder. Then the cylinder head that consists of the just wait just a second. Right. So here the cylinder head consists of the valves, right? So the inlet valve and exhaust valve
Sir,
and
video visible ಇಲ್ಲ sir.
ಇಲ್ಲ ಸರ್ ಸ್ಕ್ರೀನ್ ವಿಸಿಬಲ್ ಆகும்
screen visible இல்லையா?
இல்ல sir.
ஓகே ரைட். எப்பொழுது விசிபிள் ஆகலப்பா?
இல்ல இப்பதான் சார் நீங்க வெயிட் பண்ணுன்னு சொன்னீங்களா சார்?
இப்போதானா?
லெஃப்ட்னு வந்துச்சு சார் உங்க பேர் போட்டு.
வெயிட். இப்போ தெரியுதாப்பா? screen visible இருக்கா?
yes sir.
Okay right. So in the cylinder head will consist of the inlet valve and exhaust valve, and the inlet valve and exhaust valve will be working by using of the camshaft and the cam and the ignition system, that is a spark ignition or a fuel injector, right? So these are on the category of the cylinder head, right? These are the engine components, these are engine parts. Then the engine terminologies, right? So it is a very important one, right? So where the combustion will be takes place, right? So that's the combustion chamber, the bore diameter, that is the inside diameter of the cylinder. Inside diameter of the cylinder is called a bore, and we have two dead centers, right? Two dead centers. So one is the top dead center and the bottom dead center. While the piston is reciprocating, the region, right, the upper region is called the top dead center and the bottom region is called bottom dead center, right? Then here we have two type of volume, right? One is the displacement volume or swept volume, right? So what is the displacement volume means? The piston will be moves from TDC to BDC, that is the bottom dead center to the top dead center, right? So this volume is called displacement volume or a swept volume, right? So the linear distance is called as stroke, right? The linear distance is called as stroke, and the volume will be swept volume or a displacement volume, right? So displacement volume is a one, and second one is a clearance volume. What is a clearance volume means? The piston moves in the region of TDC, right? So the gap between the cylinder head, that is a valve section, right? The cylinder head and the TDC position, right? So here we have some limit volume, right? That limit volume is called as the clearance volume, right? So we can specify the maximum volume or total volume of the cylinder means the displacement volume as well as the clearance volume, right? So both we have to consider, right? So displacement volume as well as the clearance volume. Is it clear? Right. So for here we are using, if it is in Otto cycle, that is if it is in SI engine, we can use the spark plug. Otherwise In CI engines, we are using the fuel injector, right? So up to this, we can discuss. Sorry, we discussed in earlier class, right? Last class we discussed, right? So this class we can see the four-stroke cycle engines, right? So for the four-stroke cycle engines, we already know the what are the strokes, right? The suction stroke, compression, and power strokes, and the exhaust strokes are there. So here we can see what is the suction stroke, right? So here it is a symbolic representation. We can see in the four strokes here itself, right? So in the suction stroke or intake stroke, suction stroke or intake stroke, the air fuel mixture in the cylinder through the inlet manifold, right? So the air fuel mixture is through in the inlet manifold. It is called the inlet manifold, right? So the air fuel mixture comes through the inlet manifold, right? The piston travels from TDC to BDC, right? The piston travels from TDC to BDC, right? In downward direction. The piston travels from TDC to BDC. So while in this condition, the inlet valve is open. The inlet valve is open and the exhaust valve remains closed, right? The exhaust valve remains closed, right? So for the suction stroke, the piston moves from TDC to BDC, right? The inlet valve is in open condition, then exhaust valve is closed condition. So the air fuel mixture is through in the inlet manifold. Through the inlet manifold, the air fuel mixture comes into the cylinder, right? So for the piston movement from the TDC to BDC, automatically the displacement volume will be increases. The displacement volume will be increases, right? So here while the piston will be moved, the vacuum is created. The vacuum is created, right? So due to this vacuum, the atmospheric air as well as the fuel mixture will be sucked into the cylinder. Is sucked into the cylinder. That's why it's called as a suction stroke. That's why it's called a suction stroke or a inlet or intake stroke, right? So it is the suction stroke. It's the first stroke, right? Then after the suction stroke, the valves, right, the inlet valve as well as the exhaust valve are closed. The inlet valve and exhaust valve are closed. Then the piston will be moved from BDC to TDC, right? So the piston will be moved in an upward direction. So in the cylinder will have air fuel mixture, right? So the piston will be moved from BDC to TDC. What will happen? The mixture, the air fuel mixture will be in compressed, right? So the air fuel mixture is compresses, right? So while it is in compression, the pressure as well as the temperature will increases the mixture of air and fuel, right? So the air fuel mixture will increases the temperature as well as the pressure, right? So this is called the compression stroke. This is called the compression stroke, right? So after that, the expansion stroke is there. After that, the expansion stroke is there, right? So the end of the compression stroke and the beginning of the expansion stroke. So meanwhile, we have a process. Meanwhile, we have a process. That process is called as the combustion process. The process is called as combustion, right? So what is that combustion? The air fuel mixture has to ignite. The air fuel mixture has to ignite, right? So the combustion of the air fuel mixture occurs in very short but finite length of time, right? So the combustion process will be takes place in a very short and the finite length of time. The piston near to the TDC. The piston is near to the TDC, right? So the spark will be ignited. See here, the spark will be ignited, right? So once the spark is ignited, the high pressure and temperature air fuel mixture is burned, right? So due to this burn, what will happen? The chemical composition, right? The chemical composition will be burned, right? So due to the burning, the pressure as well as the temperature drastically increases. The pressure and the temperature is drastically increases. Due to the high pressure, it pushes the piston towards the BDC, right? Due to the piston sorry, due to the high pressure, the piston will be moved towards the TDC. So, sorry, BDC, right? So that's called the power stroke, right? That's called the power stroke, right? When the combustion is starts, right? So before reaches the TDC, right? So in the at the end of the compression stroke, at the end of the compression stroke, the piston moves towards the TDC, right? So the piston reaches the TDC. Before the TDC, the combustion will be takes place. Before that, slightly before, right? Slightly before the TDC, and when it will be lost means at the end of the power stroke, right? When will be the power stroke will ends, the piston moves BDC position. The piston moves the BDC position. So slightly before the BDC position, the combustion process will be over. Right. So this is called the expansion stroke. Is it clear? So the suction stroke means the inlet valve is open, then the exhaust valve is closed, the air fuel mixture is through the inlet manifold, and the air and fuel is sucked by the vacuum created. Sucked by the vacuum created for the movement of the piston from TDC to BDC, right? Then the air fuel mixture is compressed. The air fuel mixture is compressed through the movement of the piston from BDC to TDC, right? So while compressing, the air fuel mixture gets the high pressure as well as the temperature, right? So the at the end of the compression stroke, at the end of the compression stroke, the spark will be ignited. The spark will be ignited, right? So due to the ignition, the combustion will be takes place. That's called the compression process. That is called the combustion process. Due to the combustion, the gas and air fuel mixture will gets burned, right? So during this burning process, the high pressure as well as the temperature will occur, right? So due to the high pressure, the piston will be moves towards the downward direction, that is TDC to BDC, right? TDC to BDC. So this is called the power stroke. This is called the power stroke or expansion stroke, right? So after that, the exhaust stroke, right? The burned gas has to be go to the surrounding, right? The burned gas to the burned gas will move to the surrounding. That is called the exhaust stroke. That is called the exhaust stroke, right? So here also the at the end of the power stroke and the beginning of the exhaust stroke, right? Here we have some process, right? That process is called as exhaust blowdown, right? So between these two processes, we have a combustion, right? Combustion process is there, and between these two strokes, the exhaust blowdown process is there, right? Let the late of the power stroke, the late in the power stroke, the exhaust valve is open. The late in the power stroke here, right? So the piston reaches the TD, the BDC, right? That then the exhaust stroke, expansion stroke will be over, right? So slightly before the BDC, slightly before the BDC, the exhaust valve is open. The exhaust valve is open. Then the pressure and temperature inside the cylinder are still high relative to the surrounding, right? And the pressure differential is created through the exhaust system, which is open to the atmospheric pressure, right? So this the pressure differential causes the much of the hot exhaust gases, much of the hot exhaust gases to to be pushed out of the cylinder, to be pushed out of the cylinder, and the pushed out to the cylinder through the exhaust system, through the exhaust system when the piston is nearer to the BDC condition, when the piston is nearer to the BDC condition, right? So the exhaust gas carries a high amount of enthalpy. The exhaust gas carries out the high amount of enthalpy, which lowers the thermal efficiency, which lowers the thermal efficiency. Then opening of the exhaust valve before the TDC, the opening of the exhaust valve before the BDC, it reduces the work obtained, but it is required because of the finite time needed for the exhaust blow down. This is called the exhaust blow down process, right? So after that, the exhaust stroke, right? So during the exhaust stroke, the inlet valve is closed and the exhaust valve is open. The burned gas will be gone through the exhaust manifold, right? So it is the process of the four-stroke cycle, and these are the four-stroke cycle, right? So the same will be discussed here, right? See, in the first intake, right? So the fuel will be comes into the inlet manifold, right? The comes to the inlet manifold while the inlet valve is open, then the exhaust valve is closed. Am I audible?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, okay, fine,
Yes,
fine,
sir.
fine. So these are the four strokes, right? So the suction stroke, then the compression stroke, right? So in this compression stroke, what will happen? The piston pushes the air fuel mixture, so the temperature as well as the pressure will be increases, right? So after that, the combustion process, it's a combustion process, then the expansion stroke, then the expansion stroke, then exhaust blow down process as well as the exhaust stroke, right? So all the strokes will be here, right? Is it clear? Right. See, here it is the animation process, right? So for the first one, it is the inlet stroke, right? See, wait, see, during the inlet stroke, the inlet valve is open, the air is sucked into the cylinder, and these two valves are closed while in the compression stroke. At the end of the compression stroke, the spark, it's a spark, right? The spark will be produces here. See, the spark will be produced at the end of the compression stroke. At the end of the compression stroke, the spark is produced. That's called the combustion process. That's called the combustion process. Is it clear? The animation is clear?
Yes, sir.
Yes,
Okay,
sir.
right. The exhaust valve and the inlet valve opening by through this cam. By through this cam, the cam will be connected through the timing belt or timing chain. Right? Is it clear? It's a four-stroke engine's working cycle. Right. So for the two-stroke cycle, right? So for the four-stroke cycle, we can get a power stroke during the two revolution of the crank rotation. During the two revolution of crank rotation. See here. So the power, right? So the two revolution of the crank. See here, it is the crank, right? So the two revolution of the crank, we can get one power stroke, right? But in the two-stroke engine, we can get only one rotation of crank. Only one rotation of crank. We have to get all the strokes, that is suction, compression, and the power stroke and the exhaust stroke, right? So only for the sequence will be takes place in the one revolution of the crank, that is the two stroke of the piston, that is the two stroke of the piston or one revolution of the crankshaft, right? So here the suction as the suction and compression will be takes place in a upward stroke, and the power and exhaust will be takes place in a downward stroke, right? So here we have a two-stroke engine means, so one is the upward stroke, and one more is the downward stroke, right? So during the upward stroke, the suction as well as the compression will be takes place. The suction and compression will be takes place, and for the downward stroke, we can get a power and the exhaust stroke, right? So the difference between the two-stroke and four-stroke, right? In the four-stroke engine, instead of we are using the valves, right? In the four-stroke engine, we are using the valves, but in the two-stroke engine, instead of valves, we can use the ports, right? So here we have a two ports and plus one port, right? Two ports, and that is the inlet port and exhaust port, right? So for the inlet and exhaust valve replacement is the inlet and exhaust ports here we are using, right? So for the two-stroke cycle, we are using only the port, not a valve, right? We can see the process, right? See here, it is the inlet port and it is the exhaust port, right? So it is the inlet port and it is the exhaust port. Here one more port is there, that is called the transfer port. That is called the transfer port, right? So while in the upward stroke, the first stroke is called as the upward, right? So in the upward force, the upward stroke, the suction as well as the compression, suction plus compression will be takes place, right, for the upward stroke, right? What will happen means, see here the piston will be moved from TDC to BDC to TDC, that is the upward direction, right? So during the upward direction, see the exhaust valve, that the exhaust port is closed, the exhaust port is closed and the transfer port is closed, right? So the exhaust and the transfer port, right, so almost in the opposite direction, right? So it is the exhaust port and it is the transfer port, right? So this in almost in the opposite direction. While in the compression stroke, the inlet valve, the inlet port is open, right? So due to this port open, the air fuel mixture is sucked into the crankcase. The air fuel mixture is sucked into the crankcase, and for the upward stroke, right? So here the compression was occurring as well as the inlet also, suction also occurring, right? So the upward force will have a suction stroke as well as the compression stroke, right? The upward stroke will have compression as well as the suction, right? So both strokes, both function are there. Then in the downward direction of the piston, see what will happen. Due to the downward direction of piston, the inlet, that is the suction, will be closed, suction port will be closed, right? So the exhaust port is open as well as the transfer port is open, right? Okay, right. See, it is animation. Is it the animation is visibly clear?
Yes, sir.
Yes, sir.
Okay, right, right. See, when it is the piston moves from the upward direction, right? It is the inlet port. That is, it is inlet port and it is exhaust port. It is the exhaust port and it is the transfer port, right? So while the piston moves from the upward direction, what will happen? See, the fresh charges, right? The fresh charges come into the cylinder casing, that is called the compression suction stroke, right? So the piston moves from the outward direction, the air fuel mixture is compressed. Here the air fuel mixture is compressed, right? It is called the upward stroke, that is the suction as well as the compression, right? Here one more difference between the two stroke and four stroke is, for the four stroke engine we are using the crankcase with the lubricating oils, right? With the lubricating oils, but here we are using only the airtight cylinders. Here only we are using the airtight cylinders. Why? Because the fresh charges get into the cylinder, through the crankcase, right? So the crankcase will have airtight, right? It will not have any leakages, right? Right. See, in the downward stroke, what will happen? The power stroke and exhaust stroke will be takes place, right? So when the piston moves from TDC to BDC, when the piston moves from TD, that is top dead center to the bottom dead center, what will happen? The combustion process is, that is combustion takes place, and then the power stroke and as well as the exhaust stroke will takes place, right? So by the burning of the fuel, it increases the temperature as well as the pressure, right? So that pressure will force us to move the piston from the top to the bottom, right? So while the piston moves from top to the bottom, what will happen? The inlet port is closed, right? While it is in downward direction movement, the inlet port is closed. Then slightly it opens the exhaust port and the transfer port, right? So here also the first will be open, the exhaust port. After that, the transfer port will open, right? So see in this diagram, it will be clearly visible, right? Just wait. A screen is visible to everyone?
No, sir.
Okay, right, fine. See here the exhaust port, right? So exhaust port and the transfer port, it's in opposite to each other.
Sir, voice break.
Enapa?
Sir, screen करले sir. इतना.
Or you'll mute your mic.
Try to do sir.
Dilli Balaji. Okay, right, fine. My screen is visible to everyone?
Yes, sir.
Okay, right, fine.
Yes sir.
Yes, sir.
Okay, right, fine. See here the exhaust stroke, right? The exhaust port and the transfer port, right? So once the burned gases pushes the piston towards the downward direction, right? When the burned gas it's towards the downward direction, first it will open the exhaust port. So what will happen? The burned gases will be passing through the exhaust port, as well as at the same time the transfer port is open. That is the fresh air or the air fuel mixture from the cylinder is passing through the transport port. It's passing through the transfer port to the cylinder, right? So here the fresh charges will mix to the exhaust gas, right? Some of not a fully.
Sir, video visible இல்ல sir.
Enapa?
Okay sir. One less வந்துச்சு sir.
Okay, right, fine.
Okay sir.
Right. So in this downward direction of the piston, right, the exhaust port as well as the power stroke will be happen, right? So during the power stroke, what will happen? The piston moves from the TDC to the BDC, right? TDC to the BDC. First, it will opens the exhaust port. So here the pressure is higher than the atmospheric. The pressure is lower. So the exhaust gas will be moved from cylinder to the atmospheric gas. At the same time, the fresh charges will be comes through the transfer port to the cylinder. It pushes the exhaust gases. And the whole exhaust gas will be comes out to the exhaust system, right? So here we can note a simple term, right? So see the cylinder position, right? It has some different shapes, right? Why we are using this type of cylinders in two-stroke engine means the exhaust gases, right? The exhaust gas has to push into the exhaust system. The exhaust gas is pushed to the exhaust system by using the fresh charges, right? So if it is in flat system, what will happen? The fresh charges will be directly goes out to the atmosphere, right? So to avoid this situation, we can use the different type of shape at the top of the cylinder head, right? Is it clear? It is a two-stroke engine, right? So the working principle, right? The four-stroke engine working principle as well as the two-stroke engine working principle is clear now. Is it clear?
Yes, sir.
Okay, right. Okay, fine.
Yes, sir.
Then the difference between the two-stroke and the four-stroke engine, right? So what are the difference are there? So for the four-stroke engine, we can get a power stroke in a 2 revolution of the crank, right? But in the two-stroke engine, right, within the 1 revolution, we can get 1 power stroke, right? Within the one revolution, we can get one power stroke, but in four-stroke engine, we can get a power stroke in 2 revolutions, right? Then instead of valves, right? For the four-stroke engine, we are using the valves. At the same time, we are using the ports in the two-stroke engine. Then here the crank is not fully closed or airtight, but in the two-stroke engine, the airtight vessel is used. Airtight crankcase is used. Then at the top of the cylinder, at the top of the piston, the compression takes place. But in the two-stroke engine, at the top as well as the bottom, right, both sides, the compression will be takes place. Then here the flywheel will be comparatively larger and comparatively smaller. Then here all the fuel mixture is consumed, but here it's not like that, right? Some fresh charges will be goes out to the exhaust valve, right? So the horsepower is here high and here the horsepower is low. Then the thermal efficiency will be higher in four-stroke engine and the thermal efficiency is comparatively low in two-stroke engine. Then the torque is here produced is even, it's not less even. Then high speeds are possible in the four-stroke engine. Here the mostly high speeds, right? We know what's the difference between the Hero Honda and the Yamaha RX 100, right? Which one is the high speed engine?
RX.
So RX 100, right? Why? Because it is a two-stroke engine, right? Okay, right. So for this class, we can stop here.